Besides using factoring or square roots to solve quadratic equations, we can also use a technique called completing the square. And that's where we're actually going to use square roots, but we have to do a little bit of preliminary work to get to the point where we can use square roots. And so what we're going to have to do is we're going to have to turn the problem, so for example, x squared minus 14x plus 19 is not factorable. But what we want to do is we want to make it so that it will be factorable on one side and that it will factor into a perfect square. And by doing that, we'll then be able to use square roots to solve the problem and finish things out like we did on the previous couple of examples. So let's see how that works. So the first step we're going to take is we're going to isolate the x's on one side of the equation and move any integer pieces to the opposite side. So in this case, that means I'm going to have to subtract 19 from both sides. So I'm going to have x squared minus 14x, and then I'm going to leave a little gap here, and then I'm going to have it equal negative 19 on the other side. And so this is where the completing the square step takes place and where this process gets its name. And so the way we determine what number we're going to add to both sides of this equation, and we have to add it to both sides or else we're unbalancing our problem. So the way we figure out what number we're going to add to both sides is we're going to add half of the number that is in front of the x squared. That's what this b over 2 squared is up above. So in this case, my value of b is negative 14. I'm going to take half of it, so I'm going to get negative 7, and then I'm going to square it, so I'm going to get b over 2 squared is 49. So that's going to be what I'm going to add to both sides of my equation. Now, I'm going to get whatever I'm going to get over here on the right-hand side. So negative 19 plus 49 is just 30. But the magic is what's happening on the left-hand side of the problem. Because by doing that, I have ensured that this left-hand side will factor into the same thing twice. So I've created a perfect square. That's why we call this completing the square. By adding 49 to both sides, we have completed the perfect square on this left-hand side. And so what we're always going to factor into is x, and then whatever half of b was before we squared it. So in this case, half of that negative 14 was negative 7, so it's going to be x minus 7 in the parentheses here. And if we take a look here, that's confirmed. Negative 7 times negative 7 is 49. And then if we were to multiply negative 7 times x and then negative 7 times x a second time, that would lead us back to that negative 14x if we were to FOIL this back out. And so now this problem could have been in the previous video, where we're going to now solve by using square roots. I'm going to take the square root of both sides. And so on the left-hand side, we're left with just x minus 7. And then on this right-hand side, of course, we need the plus or minus square root of 30. And so then our last step is to just add 7 to both sides. So we get x equals 7 plus or minus the square root of 30. So we're using that square roots method, but to be able to get to the point where we could use the square roots method, we had to complete the square by determining what number we had to add to both sides of the problem so that that left side would factor into a perfect square. In the second example, we're going to get ourselves set up the same way, where we're going to pile up the x's on one side and then the integer pieces on the other. So that means I'm going to have to add 7x to both sides. So that leaves me with x squared plus 7x, and then again I'm going to leave some space here, and then I've got just the 2 that's left on the other side. Now the misfortune that we face on this one is the number that's in front of the x is odd. So that is our b. So if you'll recall, we have to take half of that, so we're going to get b equals 7 over 2. We definitely want to stay away from decimals here. Do not write that as 3.5. Don't write it as a mixed number, 3.5. Leave it in this improper fraction format. I promise it's going to pay off in the end. But now, of course, we have to square this. So my b, whoops, that's my b over 2 there. So b over 2 squared is going to be 7 halves squared or if we square that, we get 49/4. So I'm going to add 49/4 to both sides of this problem. Now again, it feels like it would be easier for us if we use decimals. I promise this is going to work itself out nicely if we just hang tight. Now, on this right-hand side, in order to add those two, I need a common denominator. So if I think of this as 2 over 1 plus 49/4, my common denominator is going to be 4. So 2 over 1 is going to become 8 over 4. So I've got 8/4 plus 49/4 is going to give me 57/4. So the right-hand side is what it is. I'll live with that. It's over here on the left-hand side where I have to factor it. But again, I'm going to take advantage of the fact that I know by adding this 49/4, by coming up with that number here the way that we did, that ensures that this left-hand side is going to factor into a perfect square. And so it's going to be x, and if you'll recall from the previous example, we determined what the other part of the parentheses is going to be is right here, half of b before we square it. So I know it's going to be positive 7/2. So as nightmarish as this looks when it's in this stage here, I know what it's going to factor into based on how I came up with that 49/4 and the pattern that I'm working with. And so now I'm ready to take the square root of both sides. So I'm going to go ahead and do that because I want to get rid of this square here, so that cancels out. So I now have x plus 7/2, and this is what I mean by things are going to work out pretty nicely for us. This square root of 57/4, I can split this up into the square root of 57 over the square root of 4, but the square root of 4, of course, is 2. And now I need the plus or minus, since we took the square root of both sides. And so then my last step is to move that 7/2 to the other side, and so we can see that we're working out pretty well here with our denominators. So I'm going to subtract 7/2. I've got x equals negative 7/2 plus or minus root 57 over 2. And now the typical way that we'll write this, instead of leaving it as two separate fractions, since they have the same denominator, I'm going to say let's combine that numerator so that it's all over 2. So it's going to be negative 7 plus or minus square root of 57 all over 2. And so this is the style that we want to write our answer in. So again, in both of these circumstances, we're getting our two answers that we would expect for an equation that has an exponent of 2. But now, since they weren't factorable, since we weren't able to use square roots outright, we forced it into a format by completing the square to where we could use our square roots approach in order to solve the equation.